Hi guys. I just thought I've had a question regarding the work in the Walker Maths book, the section on putting it together, um, with Pythagoras and trigonometry and how to put it all together. So what I thought I'd do is I'd just make you a really quick video, um, and we'll do it on OneNote here. Actually, sorry, I'm in yours, Lavinia, so let's just jump up here. Term 2. Yeah, and I'll just do a wee explanation for you, okay? You might not be able to see me in the wee picture down the bottom there. It'll probably end up pointing to my ceiling. Sorry, that's I'm going to be writing on the screen. All right, so we were looking at pages 22 and 23, okay, in your Walker Maths book called Putting It Together with Pythagoras. So at the top there, you've got this thing that says which formula to use. Is a right angle involved? Blah, blah, blah. Okay, so not as a right angle involved, sorry, as an angle involved. So we're only talking about right angle triangles, of course. So yeah, you've hopefully got that whole idea sussed that, we use Pythagoras when we're talking about the sides, A, B, and C, and we use trigonometry if there is some angle of the right angle triangle that's being talked about, not just the right angle, but one of the other angles, okay? And so then, of course, if there is an angle involved, and we're just looking at this pink box that's at the top of page 22, if there is an angle involved, then I can kind of, if there is an angle involved, then your decision is it sine, cos, or tan, and you can use soc katoa to do that once you've labelled your sides. And of course, with Pythagoras, the thing you have to decide is if you're finding the hypotenuse or a short side. So hopefully you're okay. Questions 1 through to 4. Question 4 straight away, we can see it involves an angle. You're trying to find an angle, so that's going to be sine, cos, or tan. Okay, question 2, we're not interested in any angles for that one. The side L is labelled there. That's the hypotenuse, so that's going to be a Pythag question. Okay, so continuing on, I think you're kind of okay with that. But the specific question that I've had is what we do once we start getting to these slightly complicated ones. So if we look at, say, question 6, question 6 has a interesting looking, could be a building, who knows, shape going on here. We've got that is 2.53 centimeters. We've got C, we've got a right angle there and there with C and D. This is 4.58 centimeters, and that is 5.56 centimeters. And so the question, what it's wanting to find out is how large is L, as well as how large is theta, so this angle here. Okay, so two things that we're needing to find out. So when you come across questions like this, this is part of that kind of logical thinking, in that we're going to have to split stuff up and do things in more steps than we would normally need to. So you have to step back a little bit and have a look at this and go, okay, what other information could I maybe create? Because at the moment I feel like I don't know, like this is a trapezium, this whole shape, so I don't think I know how to find a length on a trapezium or an angle in a trapezium. We haven't been learning about trapeziums. So have a look and see, okay, well, can I turn this into something that I do know? Okay, we've been dealing with right angled triangles. So can I make a right angled triangle with this question? And look, yes, I can. So how about we put a straight line across there? That's also going to be a right angle, isn't it? Because these two lines here are parallel. And we're told that that forms a right angle down here. It's not actually just because they're parallel, it's because that's a right angle there. So up the top here, you've now got a right angle triangle. And what it can be really nice to do with these sorts of questions is actually redraw the part that we're particularly interested in. Okay, so let's just redraw that top triangle. So we've got A, B, and we've got this point over here. It's not C or D because they're down the bottom of that trapezium. So how about we call it E, just for fun? And then we've got the length L, that's our hypotenuse, isn't it? We've got him that we want to know, and we've also got theta up here in the corner at angle A. All right, so what information do we know about this? So, well, we know that across here is actually going to be 4.58 centimetres, isn't it? It's going to be the same as this length here. And that is because we're told that these are parallel. Okay, so that distance, it's equidistance the whole way up that trapezium, okay, because those two lines are parallel to each other. So that means that EB is 4.58 centimetres. Sweet. And then what about EA? Can we find EA, that length there? And looks like we can. Okay, so we know that that whole long distance, and I'll use my highlighters here. This guy here is 5.56 centimeters. This guy here is 2.53. They're parallel, so there's nothing weird going on with the angles. So this distance here has got to be the difference between 5.56 and 2.53. The drawing that I've done isn't very amazing because it's definitely not to scale, but actually even the one in the book is not that well to scale either. So yeah, to work out that distance for AE there, and I'll just change my pen again, we're going to need to do 5.56, and I can do AE. The line AE is 5.56 minus 2.53 centimeters. I'm just going to jump onto the calculator that I've got here for a minute. I should be doing this in my head. I know I can't see it. But it's late at night and I can't be bothered. 5.56 minus 2.53. Oh dear, I can't move things. 3.03. Oh my goodness, I should have done it in my head, but it's okay. My brain, like yours, just sometimes feels like having a bit of a break. So line E, there we go, 3.03. So we've just created a little bit of extra information for ourselves there. And we've turned this into a triangle that we like and that we can deal with. I'm not going to finish solving this now, okay? You're going to use it, hopefully you can see, Pythagoras to find L, and then you can use whatever one you like, sine, cos, or tan, actually, can't you, to find theta, because you're going to know, all three sides, and so you can kind of choose whether you're going to use your opposite and your hypotenuse, or maybe your opposite and your adjacent, or your adjacent and your hypotenuse. Up to you. Okay, so that was question 6, and I hope that helped. Let's have a wee look at question 7. Question 7, calculate the lengths of x and y. So we've got another trapezium. So similar deal, 53 degrees, 11 centimeters. We've got a straight line here that is apparently a right angle. We've got another right angle with B. We've got the line there, Y. We've got C, 5 centimeters, D, X, and A up here in the corner. Sweet, so A, B, C, D, and then they've called that line BC, they've called it Y. So they're wanting you to calculate X and Y for this particular one. So again, X, just like for question 6, X is the hypotenuse of the triangle. Currently, you have enough information to deal with that, okay? You may be thinking, but I don't know what Y is. So how can I then find it? But you don't need to use Pythagoras like you did for 6. You know an angle in there, so you're going to be able to use trigonometry. Okay, so let's redraw that triangle with A, D down here, X, our 53 degrees, and that corner there, which let's give it a new name, let's call it angle E, okay? We knew that whole distance along here is 11 centimetres and that this is 5 centimetres, which means that this distance along here, which is going to become this distance, that must be 6. Hey, because 11 minus 5 is 6. So we actually know the length AE is 6 centimetres. And feel free to explain yourself by writing something like this. AE equals 11 minus 5. Okay, and that just, we're all about showing off, especially in this topic, showing off how you do things, showing off how you know it, okay? So yeah, 6 centimetres. So now if we just look at this beautiful little, green again, this beautiful little triangle, hopefully you can now see that you can use, what have we got? We've got adjacent and hypotenuse, so you can use cos to find x. Okay, see cos of 53 equals 6 over x. Okay, and then remembering you'll end up with 6 over cos of 53. Cool. Let's look at number 8. We've got a rhombus. We've got diagonals that meet at E. So let's draw that beautiful thing. We've got B, C, D, A, 10 centimetres, 17.89 centimetres. We've got E happening down here. The diagonals meet at E. Beautiful. So that will be a right angle. Okay, and drawn it on there. So it's the diagonals of the rhombus, then it will be a right angle. Okay. We want to calculate theta, which is this we're going here, at angle ADB, isn't it? That angle. If we wanted to use some good notation to describe that angle theta, it is angle ADB or BDA. Either of those works. So we want to calculate how big that is. What else do we want to calculate? The length of diagonal AC. So if we were to extend this diagonal all the way here. Okay, so finding theta first, let's have a wee look at U. Okay, so given that this is a rhombus, all of its sides are equal. Okay, that's the nature of being a rhombus. Okay, a rhombus is like a square that's been squashed over onto its side. So if that is 10 centimetres at the top, then all of these are 10 centimetres. We know that that diagonal there is 17.89 altogether. So that, oh, sorry. Right, sorry. Okay, so we're trying to find theta. So we'll see how we've cut this. We've got this little line that cuts right through there for the line AC. That's my cat coming into the room. Hello, cat. This is my cat, Jack. That means we're going to be exactly halfway, okay, to work out how long this distance here is. Okay, it's exactly half of 17.89, so 9.895 or something like that. Okay, so that means we've got another distance there. Okay, so it's exactly half of 17.89 because it's cutting in the middle there. Okay, it's a rhombus. It's got all these lovely sort of things about it that are equal. Okay, so we can redraw that triangle. So let's redraw that triangle. We can do it on an angle like it is on our rhombus, if that helps. We know that that's 10 centimetres. We know that that is a right angle. And we know that this is 9.895. I'm pretty sure. And you can check that. Centimetres. Okay, there you are. You know what you can do now. Hopefully you've got adjacent and hypotenuse again. Looks like there's another cos friend. Okay, and from there we then also wanted to know what AC is. That's going to be double whatever this amount, whatever that length is, isn't it? Okay, because of the nature of a rhombus. Okay, number 9. The length of AC. You've got 2 right angle triangles going on there. Okay, so it is one big non-right angle triangle, but you've got 2 that are non-right angle triangles. We want AC. Oh, yep. So first of all, find DC. So find length DC first. Okay, you'll be able to use the 9 centimetres and the 27 degrees to do that. And then you can use, so the fact that that's 105 altogether, ABC, that angle there, that's 105 altogether. Then you can also work out how big that angle DBC is. Okay, so if you look at the BCD triangle, you'll be able to work out what that is because that's 90, that's 27, so that